Alright, we're in section 4.2 here in your MathLinks 9. We're talking about scale diagrams today. A couple things from the other day. A scale diagram is a drawing that is similar to the actual one. We'll be exploring that word similar later on. We learn this could be an enlargement or a reduction. A scale is a comparison between the diagram of an object and the actual size of the object. I'll let you fill these in. A couple examples for yourself as a ratio and a fraction, and you'll see some stuff on these pages in your textbook as well to get there. A scale factor, I'm going to add in a scale factor here. A scale factor is a multiplier. Oops. To go from actual size to diagram. Oops, ran out of space there. But that's what we've used before. And in reality, as we go through this, we're going to start off by kind of using this scale as a scale factor. Here we go. So the first example, we're talking about is this scale diagram of a skateboard. The scale diagram uses a scale of 1 to 14. What is the actual length and width of the skateboard? So what this scale means is that 1 centimeter on the diagram equals 14 centimeters on the actual skateboard. So we're going to be talking again and again about diagrams and actuals, and here, as I said, we're basically using this like a multiplier, like a scale factor. So it says use the scale to find the length and the width. This is our diagram. And then the actual, it's not a lovely skateboard. We don't know its length and we don't know its width. So that's what we're looking for. So 1 to 14 means 1 centimeter equals 14 centimeters. 1 centimeter in the diagram equals 14 centimeters on the actual skateboard. So we can just multiply. We can just take length. Okay, so the length equals the 5 centimeters times 14 centimeters. Alright, 5 centimeters times the 14 centimeters equals 70 centimeters on actual. So this is 70 centimeters. And then the width would be 1.5 centimeters in our diagram times our 14 centimeter scale, or we're kind of using it like a scale factor, equals 21 centimeters on actual. Okay, so that's one way to use this, just to kind of treat it like a scale factor and just treat it like a multiplier. I'll let you try that show you know there with Chinook salmon. Gives you the scale as well. You're going to do the same thing. You're going to calculate the actual length. And now here we're going to determine, whoops, there we go. We're going to determine the scale factor for Canadian quarter. So now we're working backwards. The actual Canadian quarter has a diameter of 23.88 millimeters. Calculate the scale factor used to create the diagram of the quarter. Express your answer to the nearest tenth. So this is our diagram right here. So if you got out your ruler and you measured this quarter in the diagram, you would see that it's 1.4 centimeters. And that's just right there with the ruler on the diagram. We're going to do this one a little differently. We're going to use a proportion. And you'll see there's examples of both of these in the book. Sorry, my notes got off a little bit there. But using a proportion, we would do this. We would create a fraction of diagram over actual. And it's always going to be set up that way. You're always going to set up your proportions that way. And that right there is the scale. So we're setting up the scale. We're setting up a proportion for the scale. So the diagram measurement is the 1.4 centimeters. The actual measurement given to us in the question is 23.88 millimeters. And you know what? Let's do this. Let's just change our units there as well, so we're working in millimeters the whole time. So we just multiply by 10 to get to millimeters. Okay, I think we're back here. Sorry about that, guys. So we're just going to make a little change here. We're going to go back to our pen. 14 millimeters. There we go. So now we can just divide to find our scale factor. 14 on your calculator divided by 23.88. That gives us a scale factor of 0.5864. 0.6. So here's 10. So your scale factor here's 10 to 0.6. Another way to set up would be to set this 14 millimeters for 23.8 equals 1. But this 1 to actual, we're looking at the same thing. So the diagram would actually always be the thing we're looking for. Do the same thing at the bottom that we do the top. We divide by 14. And again, we get 23.88 divided by 14 equals 0.6. So that's another way to get our scale factor, right? Techniques there. And again, you've got some show you knows to do on the bottom there to finish that up. And we'll get that